In this video we're going to look at finding the area of a triangle. So any side can be taken as the base of the triangle, and the perpendicular height is then the height that's at right angles to that side. So again, what we're looking for here is this right perpendicular symbol, so this wee square to denote that the two sides are perpendicular to each other. So what we have is that the area of any triangle is going to be a half times the base times the perpendicular height, or it could be the base times the perpendicular height divided by 2. And the reason for that is that it's coming from an area of a rectangle. So I've put a rectangular frame outside this triangle, and hopefully we can see that the area of the rectangle would be base times height. So what we have then is, if we consider this left-hand side of the rectangle to the left of the height, the area contained within the triangle is going to be equal to the area outside of the triangle. So what we could say is that these two parts have the same area. Now similarly then, on the right-hand side of the dashed line, these two areas are also going to be the same. So we've got half a smaller rectangle. So we've got a rectangle, we've got the diagonal, these two parts are going to be equal. So what we have then is that the area of the triangle is going to be 1 plus 2, which is the same as the area outside of the triangle, which means the two areas inside and outside are equal. So the area of the triangle is half of the area of the rectangle. So the area of the triangle is going to be base times height divided by 2, or a half times base times perpendicular height. So example 3, find the area of this triangle. So what we're looking for is the perpendicular lengths. So we're looking for the right angle sine, which we've got, and the two sides that are perpendicular to each other are the 6 and the 9. So that means the area, which is a half times base times perpendicular height, is a half times 6 times 9, which is 27 squared centimeters. Again, we could make this into a rectangle, and the area of the rectangle would be 9 times 6, which is 54, but because these two areas are equal to each other, that means that one of them is going to be 54 divided by 2, which is 27. Example 4, find the area of this triangle. Again, what we look for is the perpendicular symbol. So we've got it here, and it's saying that this 7 centimeters is perpendicular to the horizontal. So the 7 is the height, and that's perpendicular to the base length. Now, although the 5 centimeters is not directly beneath the perpendicular symbol, it doesn't matter. This 5, which is the horizontal, is perpendicular to the vertical. So that means that 5 is perpendicular to 7. So the area of this triangle is a half times the base times the perpendicular height, which is a half times 5 times 7, which is 17.5 squared centimeters. Now I just want to show you by substituting a couple of numbers in for the base here, to show you why this distance doesn't matter. So let's say this distance was 2 centimeters. Then if we wanted to work out the area of the large triangle, it would be a half times the base times the perpendicular height, which is a half times 7. So 5 plus 2 is 7. Times 7, and that gives us 24.5. If we then wanted to work out the area of the smaller triangle, so the one with base 2, so this triangle here, that's going to be area equals a half times base times height, or perpendicular height, which is a half times 2 times 7, which is 7. And if we do 24.5, take away 7, we get 17.5. So maybe that was just a fluke. It only happens whenever it's 2, so let's try again. So this time with with a length of 5. So what we've got, again, the area is a half times base times perpendicular height. So if we're looking at the large right angle triangle, that's going to be a half times 7 times 10. So the full base is 10. So it's a half times 10 times 7, which is 35 squared centimeters. Then the area of the dashed triangle, so it's got a base of 5 and a height of 7. That's again going to be a triangle, so it's a half times base times perpendicular height, which is a half times 5 times 7, which is 17.5 squared centimeters. And if we do 35, take away 17.5, we get 17.5, which again is the same as the area before. So it doesn't matter whereabouts this point is, whether it's anywhere to the left of where it currently is or anywhere over on the right, provided the 7 centimeters remains perpendicular to the 5 centimeters, then the area is a half times 5 times 7. Example 5, find the area of this triangle. So what we've got is the area is half times base times perpendicular height. So what we're looking for there is the right angle symbol, which we can see is here. And the first side that is at right angles is going to be this 10. So that's going to be the height of the triangle, and the side that it's perpendicular to is the 8. So it's these two measurements we're going to use. So we're going to do a half times 8 times 10, which is then going to be 40 squared centimeters. So one extra example just want to look at is if we have a triangle whose area is 30 squared centimeters and base is 10 centimeters, we want to find the height. So we could draw any right angle triangle. We've got the base is 10 and the height is what we're looking for, and the area is 30. So area is a half times the base times the perpendicular height. We know the area is 30. That's going to be a half times 10 times the perpendicular height. Now we can work out what a half times 10 is, and that's 5. So we get 30 equals 5 times the perpendicular height. And if we divide by 5, that'll leave the perpendicular height on its own, and we get 6 equals the perpendicular height. So that means the height would be 6 centimeters. And it would be the same, would be true, the same technique we would use if the perpendicular height was given to us on the base. We'd work out what a half of whatever that is, and then we'd divide the area by that.